This is Rough Science, coming to you from the Spice Island of Zanzibar off the east coast of Africa. Our scientists face their toughest trial yet as they take on the ocean. They have to complete a set of marine challenges with a few simple tools, basic kit and a boatload of ingenuity. Our base on the Indian Ocean is a traditional fishing dhow, and our site on land is an isolated beachside workshop. It's destination paradise for Rough Science. Our four scientists are Kathy Sykes, a resourceful physicist with boundless energy. Mike Bullivant, an imaginative chemist who embraces the near impossible. Ellen Macaulay, a fearless have-a-go botanist from Missouri. Jonathan Hare, physicist, inspired inventor and artistic engineer. And me, Kate Humble, an experienced diver. I'm going underwater to put their inventions to the ultimate test. Together we are Rough Science. Well, it is the last programme, and to celebrate, we do have the ultimate challenge for all of you. It's a group challenge this week. I want you to come up with some sort of underwater breathing apparatus so that I can go and swim with the fish. So
your trust in us is touching.
I know. Probably verging on the insane. But anyway, Kathy and Jonathan, you're going to be in charge of supplying my air and monitoring it, OK? And Mike and Ellen, you are going to come up with some weighting device which is going to allow me to be neutrally buoyant so that I can hang in the water. I don't float on the top, and nor am I pinned to the sand at the bottom. OK?
You're mad.
You have 3 days, everything in the workshop, all the stuff that you can find around here, and, of course, magic trick. Jonathan is going to get air to me, Kathy's in charge of my air tank, and Mike and Ellen have got to keep me safely underwater. This is a risky challenge for me personally, and this week I've given them a few bits of essential kit to help them along. A diving regulator, a car tyre pump, some lead and a beer barrel. Now, you both looked at me in absolute horror, but is it really going to be that hard to supply me with air when I'm underwater?
Well, if you were just a little way underwater, 10, 20 centimetres, we could just give you a snorkel.
Yeah.
But the problem is, the deeper you go, the bigger the water pressure. So we have to provide air at the right pressure for you to breathe.
Why is that, though?
Well, basically, it's all the water above you is squashing everything. But your whole body's at higher pressure. Your lungs just can't expand to breathe normally. So the only way that you can breathe normally is if we supply you with air at the pressure of the water that you're at.
Wow.
So that means the air that we feed you has to be compressed, basically. We have to build a pump.
Right.
Because you're just not built to suck air.
So getting air to me at the correct pressure is essential. But Mike and Ellen's task is just as important. They need to establish how much weight I need to be neutrally buoyant so I can float in the water at a constant depth.
Hey!
Right. You want me to do what?
We need you to get in the water. Completely submerge yourself so we can figure out what your volume is in water, because we're going to collect it in this bucket here.
OK, and you need my volume why?
Well, if we're going to make weights for you that make you neutrally buoyant, we've got to figure out exactly how much you need.
And volume will tell you?
Volume's the first step. Then we have to weigh you.
Oh, good. One leg at a time?
Very slowly. You ready, Mike?
Yep.
Okay, I'm just going to lean on you.
All right.
Right. Just ease myself in.
Yeah. How are we doing? We collecting?
Yep.
So basically, we're getting the amount of space your legs take up, but we're getting it in terms of seawater.
OK, well, now the big bit's going in. Bottom half.
I hate to tell you, but you're going to have to put your head in, too. We have to go slowly, Kate, because if water comes out here, we've blown it.
OK. How long do I have to stay submerged?
You want your head under the water for as short a time as possible. I'm sure you do, too.
Yeah, it doesn't look very pretty in there, I have to say.
We're still pouring out of here.
Ooh, careful, you're getting near the surface. It can't spill over.
Good for the stomach muscles, I'm sure. While I'm being immersed for my volume, Kathy's found a use for the beer barrel.
Now this is Kate's reservoir of air. That's the idea. We hold it at the sea bottom, same level as Kate, gives her the right air pressure. This whole volume of air has to be weighted in order for it to stay at the sea bottom. So what I want to do is fill this bottom container with a load of weight, attach it tightly to this, and then sink the whole thing.
On the beach, it's time for me to go under completely.
Right, ready?
Yeah.
Okay.
Okay, that's it. All right.
That'll do. Just before the tide came in.
What things I do for science.
Just Kate.
Now Ellen and Mike have got this measurement of my volume, they've got to weigh me. I hope that's going to be more fun. In the workshop, Jonathan has got an idea about how to supply me with air underwater.
What are you doing to my beautiful car pumps? I thought that was going to be the kind of crucial bit of this whole machine.
They're not big enough. Because if you think about it, that much air is like a fifth of a breath. So I'd have to pump incredibly fast to be able to get enough air for you to breathe, you see.
Yeah.
So I could fill up the reservoir slow as I want, but then when you started breathing, you just lose the air really quickly, and then I wouldn't be able to keep up. So I need to make a bigger pump.
Just looking at this, I don't think I've... Can I have a look inside? I don't think I've ever seen inside a pump. How does it actually work?
It's really simple. You have a tube with this piston on, and when you push it along the tube, it compresses the air, which obviously forces it out.
Okay.
There's actually a little plastic ring here, which when you push it, compresses the air, and when it pull it back, it lets air in. It's a really clever little thing. It's very simple. So what we're doing now is I'm going to have a much bigger tube here.
Oh, okay.
So that each sort of stroke of the pump,
Yeah.
I can get much more air down to you, and you're not going to run out of air for you.
Of course.
We're halfway through day one and the whole team has settled into the build. Ellen and Mike are working on the next stage in giving me the correct amount of weights to keep me neutrally buoyant.
This is just a seesaw that we're going to hang from this tree. What we have to do is balance the seawater she displaced from the bathtub, balance that with Kate plus some lead weights.
Sounds straightforward enough. Let's hope a plank, a tree and a length of rope does the trick. What's worrying me most at the moment, though, is how my air supply is coming along.
The idea is that this stays still, you get the full volume of air for you to breathe,
Yeah.
and then we just have a little pipe coming out the top.
And that's for me to breathe off.
Exactly.
So what do I have to do? Just sort of sit at the bottom breathing off here?
Well, you can swim about.
Oh, so it'll be quite long.
Yes. Also, I want the air in here to become the same pressure as the water pressure when it's quite deep.
Yeah.
So if I have holes in here,
Yeah.
when we lower it down, this will just fill with water.
Yeah.
We pump from the top.
Yeah.
And we fill it up with air that is now at the right pressure for you to breathe.
So the air being pumped in will displace all the water down here. That air will be at the right pressure so that this doesn't collapse and also I can breathe it and it'll all work beautifully. That's quite ingenious, isn't it?
Oh, so I'm going to be able to move underwater with their homemade diving kit. I'm beginning to look forward to this, but it looks like Mike and Ellen's homemade scales aren't off the ground yet.
We've got it in the middle fine. It's just the
If you suspend it, you see this end is heavier than that end. And it's because the mass of the wood is not uniformly distributed along the plank. So we could either cut some off that end so it balances horizontally, or we could add weight to that end.
If this length is not the same as this length, each time you add more mass to the shorter length, it's going to have more effect later.
I see what you mean. Right, so we add weights rather than take that off there.
Yeah.
The distance has to be the same. Yeah, you're right. You're right. We add weights to that end.
Oh, this end? Ah, perfect. Oh, Mike, that's fabulous. Right like that. I think that's good. And like slowly put our weight on it?
Yeah, you count to 3 and then lift our feet off the ground.
Okay. Oh, look at the board.
Yeah.
Whoa, 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 the board is gonna crack.
It's twisting, isn't it? Why is that twisting?
We could try to stabilize the board on either side with another piece of wood.
It really needs to be thicker so it doesn't bend, it doesn't ply.
We're well into the afternoon now and these seesaw scales are not looking promising.
Still bending.
Do you think it's gonna be good enough, Mike, though?
As long as it doesn't break. We've balanced it up so it's horizontal, and we check that against the horizon. And we assume the sea is flat. So now we put Kate on one end, water on the other end, and there will be an imbalance, which we have to get into balance again by adding the appropriate number of lead weights. And that number of lead weights is what we use to give her neutral buoyancy in the water.
And if I'm not neutrally buoyant, I will either be stuck on the seabed or floating on the surface, so they need to get it right. And another thing that needs to be got right is my air supply.
Don't like the look of that, Jonathan.
It's great, it's working really well.
No, it's
loads
not.
more.
Look at that. It's putting air in, but it's taking it away again. That's going to be no good to me. I'm going to take one breath and go...
Obviously, when the piston goes back to get more air in, it's actually dragging the air back in again.
Yeah.
So I do need a one-way valve on there, because what we want, when that air comes out, we want something to stop it going back in there. So I've got to figure out a way of making a one-way valve on the end of each of the pumps.
Yes, please.
So, yeah.
I'd be quite grateful if you did that.
That's the next thing I've got to work out.
I'm going to leave you in peace, but just don't stop. Keep trying.
This is not a challenge with second chances. I'm going to be swimming in the ocean at a depth of 3 to 5 metres. I'm depending on Jonathan and Kathy to overcome the force of the sea above me and supply the air I need to survive down there.
Well, I've been working hard on trying to make everything completely airtight. If she gets a lungful of water, then it would just terrify me. And you've got all that weight of water above you. Even if she has to suck to get air, then it just makes it a really scary experience. I think she's being really brave.
And not too trusting, I hope. It's an hour before sunset and Mike and Ellen look like they're finally ready to test their scales.
Okay, so this is Kate's volume in seawater.
Yep.
And we expect it to weigh more than Kate because seawater is denser than we are.
Yep.
Okay, so let's see if this balance can take this weight.
Well, let's go with that.
I don't know how we're going to tell if it's balanced like this.
Oh, my God.
Are you okay?
It's my turn.
Right, I've got my wetsuit now. What do you want me to do?
Sit on the other side of the balance.
Oh, okay.
With the holding your wetsuit.
Holding the wetsuit?
Yeah.
Okay. Oops.
Oh, that's way off. Kate is far heavier than the water, which is the wrong way round.
So in other words, the measurement we took when we put Kate in the bath
Was not accurate enough.
because we know Kate is less dense than seawater, because if she just went out there, she'd float. And that's because you're 60% water, but you also have a lot of air in your lungs and your tissues. So we must have been inaccurate when we sunk you.
Okay.
We didn't collect the water carefully enough.
Do you think it was because my knees were sticking out of the top?
That's very possible, or we didn't wait until the water got really level, so we're going to have to sink you again and do this again.
Oh,
You get to take another bath. Come on, Katie.
Well, it seems like my underwater expedition is reliant on a beer barrel, half an oil drum, a broken car pump, and some copper tubing. My life seems to be hanging in the balance, and not a very accurate one at that.
Day 2 and the team have only 24 hours to finish my rough science diving device. Then I'm going into the sea to be their underwater guinea pig.
You made some adjustments to the balance.
Yeah, it should work better.
Okay.
Less fiddly.
And is this my new volume?
This is the volume we got with you when we sunk you the second time last night, and
Yes.
we're much more careful.
I know, thank you. Practically broke my legs doing it. Shall I go and get on the seat again?
Please. Now, you should go off the ground.
I am going off the ground.
Let's just start handing you weight.
I'll check the horizon.
Okay.
Okay.
So now what we need to do is add weights to you
Right.
until the balance is level.
Okay.
which means that you will then be neutrally buoyant in seawater.
Perfect.
Okay, let us know when it balances, Mike.
Yep.
Woohoo!
I'll keep adding. You've got a long way to go. It's beginning to move
Okay.
towards the horizontal.
Let me get some more.
Go on.
Oh,
Yeah, it's beginning to move. And another one.
How many is that? 5, 6?
Try one more. It's very
Okay.
close. That's it.
Yeah?
that
That's
it?
level now. That's level.
Wow. Now, can I just venture a small question here?
Yeah.
What am I actually going to do with these? I've got to just carry them down in my hand.
Stuff them in your pockets. No, I'm going to melt this. Ellen and I are going to melt this lead and
Right.
make a weight belt for you so you've got your hands free.
Things are looking up this morning. I wonder if Jonathan has made any progress keeping my underwater air supply constant.
OK, well, this is a computer mouse ball, which is actually quite heavy and it's perfectly round. And it's got a sort of rubber layer on it, and I'm hoping I can use that for the runway valve. So this is a fitting that's going to be on our valve, on our pump that we just made. And if I put the ball in there, if you imagine that the pump is pumping, that'll be me blowing. You can see that the air comes through the system and blows the ball out of the way. So if I suck on this now, I can't do that at all, because the ball just goes down, is sucked down into the copper groove and seals it.
So air will go into my tank and stay there. Down on the beach, Mike and Ellen have already built a chimney for their lead melting furnace.
This piping leads off from a big filter funnel over the pot in which we're going to melt the lead, because molten lead will give up quite a bit of vapour, and that vapour is toxic. So we have to make sure that any vapour that is given off is allowed to condense, and it should condense in this PVC tube, but if I put that in there, there's a greater chance that no lead vapour will come out of the end of that tube there and pollute the environment, and the lead vapour that's given off will condense as a film of solid lead in here. So I'm fairly safe that we're not polluting the environment with this thing.
The rough science industrial revolution is underway. Even Jonathan's doing some expert soldering on my air pump.
Oh, now that looks altogether more promising.
Definitely, the one-way valves are in there.
Yeah.
And so it's pumping out, but not sucking back in now.
Brilliant.
So it's really...
And quite a good rowing system here.
Yeah, so when one is pumping, the other one's filling up with air. So actually, as you move, there's always one pump supplying air.
Brilliant.
Can I have a go?
Yeah, so
You
just
push-
push this way.
Yeah. Let's
Okay.
see if we can get this balloon.
Oh, my goodness!
Hey!
Fantastic. Well, as long as that doesn't happen to my lungs, I'm a very happy girl indeed.
So we got this in the trunk, the seatbelt, which we could use to thread the weights on for Kate.
Yeah, and this offers her a quick release mechanism if she has to drop the weights to come to the surface.
But the only problem is this isn't coming out at all.
I think we'll have to smash this up.
Yeah.
Take a hammer to it. Yeah.
All right, so that'll work.
It better had. Kathy's been busy all morning fine-tuning my air tank, and now she's come up with a way of checking that I have enough air in there.
Now, this is the device to try to keep track of just how much air there is in the reservoir. So this thing here is going to move up or down according to where the water is. So I know exactly how much air Kate has got left.
Looks good to me. At the beachside production line, Mike and Ellen are ready to pour.
So, Mike, are you telling me that literally you can put that lead in that saucepan and it will melt?
Yeah, the fire's at a hot enough temperature to melt the lead. It melts at a particularly low temperature, like something like 330 degrees Celsius.
Right. It's just amazing to me that you can reduce a metal to a liquid form over what looks just like a campfire.
It is campfire, yeah. You wouldn't be able to do it with many metals, but lead is one that you would be able to do it with.
And what are you doing? Are you making mud pies?
I'm making a mold in which to pour the lead. And the lead should solidify almost immediately. Now, this sand is a sand and glue mixture, so the lead shouldn't splatter at all.
OK, it's ready for casting. I'm going to stand back.
Shall I stand back a bit as well?
I would, Kate, yeah. Let's leave it to Ellen.
Okay, that's one. Isn't it beautiful? Oh, it's so much heavier now. It sets really, really quickly. I can take this off now. Ready?
Can I touch it?
No, it's too hot.
Okay.
But would you like to do the honors?
Yeah, what are the honours?
Flip it out onto the ground.
So we just let them cool down,
Yeah.
and then we can scrape the sand off them. We've got some more to do.
It's absolutely brilliant.
And when they've finished, they'll have the right weight to make my dive belt. It's mid-afternoon and everything is coming together. Kathy's joined in the casting and is using up the spare lead. She's making some unusual weights to pin her air reservoir to the seabed. After a frantic 8 hours, Kathy and Jonathan join forces to do the first test of my breathing device in our water tank.
OK, and now
Rocks.
start loading in some rocks.
This is going to be an awful lot easier when we have Ellen and Mike's lead.
I hope. Much easier.
Well, actually, once this goes over the lip, the water
I-
will come in, won't it?
Yeah.
And it'll start to sink. That's interesting.
What does that mean?
You can hear it out coming out.
Nasty hiss.
Yeah, we've got a bit of a
We've
leak.
got a bit of a leak there.
I'd say that is a bit of a leak.
Not good at all.
It's like Rocky's championship belt.
Wow.
And it's a release with your right hand. Can you hold on to that?
Yeah.
So to release it,
There's an emergency.
in an emergency, divers always use their right hand. Drop the belt.
And she goes,
Perfect.
boom, right up to the surface.
Yeah. We need to do some needlework or,
We'll tie it.
yeah.
Actually, we need to do a fitting with Kate.
Yeah.
Hey, you're doing good. You're doing good. In fact, you've just about filled her and she's about to go over it.
Okay.
Yep, that's great. Yep.
Quite hard work.
Okay.
If the air is hard to breathe on land, will it be a strain underwater? I don't know, and I'm getting a bit apprehensive about tomorrow. Day 3, and we've sailed to the island of Nemba on Zanzibar's east coast to debut my rough science diving device. The sea here is always calm, and at 3 to 5 metres deep, it's the safest place for me and my lungs. But there's no room for failure on this. The acid test will be if I can breathe air while I'm swimming underwater. I'm beginning to regret setting them this challenge.
Everyone, I'll take this one up here.
Right, are we all set?
I think so.
What do you think? Yeah, quite nerve-wracking. It just really looked like a beer barrel this morning, I have to say. OK, well, where do we start?
Well, we need to lower that over.
OK.
Yeah, and then put it up with some of the weights.
Right.
My air tank is on its way to the seabed. The homemade weights and chains should keep it in position.
Feeling good.
It's sinking. So at this moment, Kathy, is water pouring in through the holes in the bottom of the beer barrel?
There will be some water going into those holes.
Yeah.
But since there'll be some air at the top, it's probably just compressing it.
OK.
So, hey, we can't see bubbles pouring
No,
out.
so it's obviously sealed.
So that's
great.
good.
No leaks. Now, what do you need to do with your gauge?
It will just involve a bit of untangling.
In goes Kathy's all-important safety gauge to monitor my air supply.
Okay, well, it's floating reasonably well, and we can see the top of the gauge.
Yeah.
So I think we're ready.
Great.
OK. So what's the next stage?
Well, I need to fix the bottom pole.
Yeah.
And then we'll be ready to calibrate, so we know when the tank is full and when it's empty, before you even have to go down.
OK.
Kathy is making sure that the safety gauge will give her an accurate reading of my air supply.
Okay, it's ready to go. At the moment,
Yeah.
it's got no air in, so this is the point where Kate is going to be really miserable.
How is this actually working?
Well, there's a big float inside the air reservoir.
Okay.
And that is just tied on to this little pole here.
Yeah.
Which is going to raise and lower according to how much air is left. And this point here, that's the danger point. Now what we're going to do is start the pump, fill it up with air, and then the whole idea is that we'll then be able to mark off where you'll be very happy.
Good. Okay.
So do you want to start pumping?
Yeah. How's it doing, Kathy?
Working.
So we know now that as the air is going into the reservoir, it's pushing water out of the bottom, so the water level is dropping.
That's right.
Oh, no, hang on, is that bubbles coming up?
need that again,
I think we might be full.
Bubbles are coming up, guys.
Great, so that's the full mark.
Now, shall I just try this very quickly, see if I'm getting any air?
Yeah.
Yeah, there is. It's working. Right, come on, I can't put off the evil moment any longer.
Is it fully pumped, guys?
Don't know, we can keep on going.
Give it another pump, because according to this, it's about, it's a little bit empty in there.
Yep, okay.
Okay, good, it's going up nicely.
Are we
Ready
full?
to go? We're full.
Great.
Okay.
This is it. I'm completely in their hands. From now on, every breath I take will be supplied from above.
She's breathing. Hey, get pump it.
We need pumping.
It's half full.
Are we beating our breathing?
Yeah, it's rising. Yes, it's
Okay, you're
prison's
just
almost
about
full.
full. She says she's okay, and the weight belt is okay as well. Her buoyancy's looking great.
It's actually easier to breathe down here than I thought. That must be because the air in my tank is at a higher pressure than the air at the surface.
Okay, guys, pump again, half full. Hey, she's just swum off to look at the reef now. She's just having a great time.
She's way over there.
Okay,
look.
full.
I'm swimming 4 meters below the surface of the Indian Ocean. My dive belt is so accurately weighted that I can move around with almost no effort at all. They've given me the freedom of the sea, and I don't want to come back up.
Okay, you're full.
What it was.
Pump it, please.
Cheers.
Oh, we got pump.
It's been down there for ages. Here she comes, guys.
That was amazing! Woo! Oh, absolutely fantastic. The coral down there is beautiful. I could breathe, no problem at all. Can I watch you that?
Oh, brilliant.
The weights were absolutely perfect. Did you see me signalling? I was just hanging absolutely in the perfect position. And sadly, that is it for rough science. Jump in, guys. Come on, guys, get in here.
For a free magazine about all Open University programmes, call 0870 900 9581 or go to open2.net, where you'll also find more about this week's challenges.